Welcome to The Explainer. Today, we're diving deep into space, one slide at a time, to really get to the bottom of the massive engine that's powering a distant galaxy. All right, we are pointing our telescopes way out there, into the Virgo cluster, to investigate a galaxy called Messier 84. Now, if you just looked at it, you'd think, oh, it's a quiet, giant elliptical galaxy. But trust me, deep inside, it's hiding a ridiculously powerful secret, one that's helping us figure out how galaxies actually evolve. So yeah, let's do that. Let's follow the clues and piece together the puzzle of what is really going on at the very heart of M84. Okay, so our investigation starts right here, with M84 itself. You gotta understand, this isn't just some random galaxy. It's one of the heavyweights in our cosmic neighborhood, a huge collection of stars and gas we call the Virgo cluster. And just to wrap your head around this scale we're talking about, M84 is about 55 million light-years away from us. That means the light we're seeing from it tonight started its journey when giant mammals were still roaming our planet. It's just mind-boggling. For the longest time, astronomers just saw M84 as, a pretty standard, if really big, galaxy packed with old reddish stars. But they also noticed this faint radio glow coming from the center, and that's a telltale sign that some kind of powerful engine is hiding in there. And that little clue leads us straight to the heart of the investigation. All the evidence points directly to the galaxy's center, where we find the prime suspect behind all of this cosmic action. So get this. Back in 1997, a team used the Hubble Space Telescope to clock the speed of a disk of gas swirling around the core, and it was moving at a blistering 400,000 kilometers per second. I mean, the only thing that can whip gas around that fast in such a tiny space is something with an absolutely immense gravitational pull. The math pointed to one thing: a central engine of incredible scale, a supermassive black hole with the mass of 1.5 times billion suns. That's not just big, it's an almost unimaginable cosmic monster. But what's really amazing is what this black hole is doing. It's not just sitting there. Oh no, it's actively powering one of the most dramatic and energetic things in the entire universe. For years, when we looked with radio telescopes, we could see these giant structures, what we call relativistic jets. Think of them as twin beams of particles shot out from the black hole at nearly the speed of light, all funneled by these super powerful magnetic fields. And here's where it gets crazy. For a long time, we figured these jets only shined in radio waves. But then, astronomers were digging through old Hubble images and got a massive surprise. The jets were right there, clear as day, shining in the same kind of light our eyes see, and even in ultraviolet. Nobody expected that. This discovery was a total game changer. It showed that M84's jets aren't simple at all. They've got multiple, distinct energy parts, all coming from the same spot. This basically turned M84 into a crucial laboratory for studying these rare and really complex MSC jets. It's really pushing our theories to the limit. Okay, so here's the crucial point. This engine isn't just some isolated thing. Its jets are having a huge impact on the entire galaxy. They're literally carving out its structure and controlling its destiny, in a process scientists call feedback. And when we look at M84 with an X-ray telescope like Chandra, you can see the evidence of this feedback, and it is spectacular. The jets have acted like cosmic blowtorches, blasting out these enormous bubbles in the hot gas that fills the galaxy. It even creates this really distinct H shape, and this whole process is what's stopping that gas from cooling down and making new stars. So this whole feedback thing creates a fundamental problem at the center of the galaxy. The black hole gets its power by eating gas. That's its food. But the jets it creates are literally pushing that food away. Now, I know this quote looks super technical, but it comes from the deepest X-ray look at M84 ever. And it reveals a profound paradox. The Bondi accretion rate is basically how much gas should be falling into the black hole. But what this team found is that the actual power we see coming out is way, way less. So to put it simply, the black hole is starving itself. There's enough gas around for it to be 10,000 times more powerful than it is, but its own jets are just so good at clearing out the area that almost none of that gas ever makes it to the event horizon. But, despite everything we've figured out, the case of Messier 84 is far from closed. In fact, it kind of feels like every new discovery just opens up a whole new can of worms. And these aren't just small details. We're talking big questions. Like, Why are M84's jets less focused than others? Could there be some hidden stream of cold gas fueling it that we just can't see? And we're still trying to get our heads around the exotic physics that makes these jets glow in visible light and X-rays. Answering these could totally rewrite our models for how all galaxies work. And this really brings us to the ultimate question M84 is asking us. It's not nearly as crazy and active as its famous neighbor, M87, but it's way more active than the quiet black hole we have in our own Milky Way. That puts it in this perfect in-between spot. It could be the missing link we need to finally understand the full life cycle of these cosmic engines and the galaxies that they call home.